won't be able to. Right. So what are inorganic compounds? So inorganic compounds are compounds which are not majorly formed by carbon. Right. So what are organic compounds? Organic compounds majorly contain carbon in their molecular formula. Compounds which contain carbon are called organic compounds. Hari. So in organic chemistry, we learn how these kind of compounds, for example, we can write CH3, CH2, CH2, CH, double bond, CH2. So these kind of compounds, also the benzene ring, if you have heard it, something like this. And then there is carboxylic acids. So it's a weird kind of molecules for you. They are weird kind of molecules for you. So we're going to learn how these molecules behave, react, and how to identify these molecules in organic. Also, we learn how to name these compounds like we learned in inorganic nomenclature. We are going to learn it for organic nomenclature as well, right? How to name these compounds. Okay. Now, when you are doing organic in another class, if you attend another class and if you are doing organic in that class, they will teach organic all together like a fruit salad. And a fruit salad, there is banana, there is grapes, and there are like, is there grapes in fruit salad? There's no grapes, right? Normally they don't put grapes, right? Okay, forget about grapes. There's apple and there's banana and there's pineapple. And what else is there? Mango is there. Tell me some fruits in fruit salad. What are the fruits in fruit salad? What are the fruits in fruit salad? Tell me. Anyone? Pepper, right? Okay. Papaya. Oh, pepper. Yeah. Okay. Anything else you put in fruit salad? No, right? Dates, okay, whatever, right? So there are different fruits you put in fruit salad, right? That is how they teach organic to you in another class, especially in schools. But in our class, I'm telling you the reason why this class is better at the beginning of the class is because of this. We are going to break down organic into 6 sections. First of all, 1, 2, 3, 4, 5, and 6. So first of all, we are going to learn about reactions of organic. We're going to learn about reactions of organic, and that is what we are doing today, right? Reactions of organic will take around 5 classes to complete together with conversion practice. What is conversions? What are conversions? So conversions is a special kind of question pattern where we learn through the reactions. I'll teach you that later. So there are reactions and there are mechanisms. There's something called mechanisms. It is directly correlated with the reactions because in reactions, a reaction is happening, and in mechanisms, you're going to learn how that reaction is happening, right? How that reaction is happening. So after reactions, mechanisms, and then you have identifications. You have identifications where you learn how to identify the organic compounds. For example, when you add 2,4-DNP, you will get a reddish color solution. So what is the compound related to that? So that is what you're going to learn. That is what you're going to learn under identification. So how to identify, right? If I ask you to how to identify ethanol, right, you should be able to identify that. So that is what you're going to learn under identifications. And then after that, we're going to learn variations. Under variations, there are like 3 to 4 variations you're going to learn. There's the carbocation stability variation. There's the acidity variation, how organic compounds vary in acidity. And then there's the basicity variation, right? So these are the variations which you learn in organic. And then after that, we have something special called isomerism. I won't go through much detail under this because this is a separate topic and you need some organic knowledge in order to understand this. So I will not teach you that now. I'll tell you that there's a topic like this, you're going to learn that also. And then finally, nomenclature. Nomenclature, you know, it's about naming organic compounds. Samara class make karna isala. This is what they do first. They do nomenclature first. They learn how to name the organic compounds you have never seen in your life. Then only they go for reactions, mechanisms, and then identifications and isomerism all together. In my first try, I went to a class. So that person, sorry, I'm not supposed to tell that person. That sir, sorry, that sir did nomenclature first and then isomerism and then these 4 together. That's how it goes. I never understood organic for like 3 months. For like 3 months, I was done. Like I was not able to do a conversion. I was not able to do a small question even from organic. Like it's very hard to study the reactions and everything. Like it's going to be a mess. That is why I'm coming up with this, where we learn isomerism and nomenclature at last. Because you don't know organic compounds, first of all, in order to deal with it. Mam boru nan kiyane, you can see it. Like after just 1 month, when they start organic, you can see it. I won't tell the name of the teacher, but normally that is how it's done. It's not going to work like that. So that's why we're going to start from reactions and then we're going to move into the other parts, right? So reactions. What are reactions? So under reactions, there are different compounds which we learn. There are different compounds, types of compounds you're going to learn, right? Now in inorganic, you don't have types of compounds. So all compounds are individual to them. For example, sodium hydroxide. They don't belong to a certain category. But in organic lamai, you can divide compounds into categories. We can say alkanes, alkenes, alkynes, alcohols, alkyl halides, alcohols, alkyl halides, and then phenol, right? Phenol, then benzene, then what do you have next? You can have amides and amines, and likewise, there are different categories of compounds. Right? There are different categories of compounds, but everything contains a carbon chain. There is a definite carbon chain in all of those categories. So when you attach an OH into this, you give a specific name to this. You call this an alcohol. If you attach a NH2 here, we call it as an amine. Let's say you attach a chlorine. This is called alkyl halide. Raise your hands if you understood that. You have a carbon chain and then you're going to attach different atoms like chlorine, OH, and then NH2 and stuff. And then the name changes. The name which you give to that compound, the basic name which you give to that compound changes. So in this case, this is a alkyl halide. Raise your hands if you understood. There's a raise hand option in Zoom if you don't know. Everyone, come on. Be active. Huh? One more thing, if you're joining to my class, you have to be active in the class. You have to be active in the class. You have to respond to messages. You have to raise your hands. You have to ask doubts. You have to do questions. If you are not someone like that, if you are an introvert who cannot respond to messages and you're shy to talk in a class, then don't join. You can leave the meeting now itself. Don't come to the class. So raise your hands if you understood this. That's the carbon chain and you attach different atoms into this and the name changes according to that. Got the basic idea of reactions and compounds. Got the basic idea of compounds, right? Okay, so let me go through all the compounds which we have. Now, this is important if you can write it somewhere, right? Write it somewhere in a separate sheet of paper or something. Haril, just to have an idea of what are the compounds. We have alkanes. We have alkenes. Right? We have alkenes. Then we have alkynes. Right? We have alkanes, alkenes, alkynes, and then we have alkyl halides. Alkyl halides we have. Then we have alcohols, and then there's benzene, and there's phenol. Benzene, phenol. Then we have aldehydes. There are something called aldehydes, which are similar to ketones. Right? These are not just normal names. Hari. Then ninth one, we have something called carboxylic acid. There's something called carboxylic acid. Then 10th one, we have esters. 11th one, we have acid halide. We have something called acid halide. And then 12th one, we have amides. And then we have amines. And then we have something called diazonium salt. So these are the compounds you're going to learn under organic. Right? These are the compounds you're going to learn under organic. Okay? Hari. So we are not going to go deep into all the reactions here. Api reactions are deep. Now the first topic I told you, we are going to learn about reactions. We are not going to learn how the reaction happens. We are not going to learn the mechanism of the reaction. Because I want you to touch organic from the surface. Just touching through the graph. You're just touching the graph up and then getting an idea of what is organic. And then we go into the deep mechanisms. Otherwise, you will mess up everything. A lot of students mess up. Right, around 90% of students do not understand organic until around 3 to 4 months. Masa tunak khatarak kanakan, you can't do conversions. Look at your friends after 3 or 4 months, you can look at them. You will see this through your eyes. They can't do organic conversion until 3 to 4 months. That is how it happens. But now we are going to go through the reactions by touching it on the surface. We are not going to learn too much deep into it. We are just going to learn the reaction, reagent, and the product. All you have to do is memorize the reaction and then apply it into a conversion. That's how it happens. So write this in a separate sheet of paper or a notebook or behind your book, somewhere where you can see it. You don't need to memorize these things. No need to memorize. These are just compounds which you find in organic. We're going to discuss about them. Hurry. Raise your hands when you're done writing this. Hari, තව දෙයක් කියන්න. One more thing I'll tell you. Now let's say like now today's class is free නේ. ඊළඟ class එක you have to join with the month of June, right? 2027 month එකට join වෙන්න ඕනේ. Let's say if you join, we are giving you a gift. අපි ආඩ දෙනවා gift එක. We are trying to give you a gift. Now what is the gift? Now we have completed until inorganic. Inorganic සම්පූර්ණයෙන් complete කළා නෑ. We have not completed fully, but I will give you the chance to buy one of the 6 units. One of the first 6 units as a study pack. You can choose it. If you want energetics, okay, fine. I'll give you energetics full study pack to you to learn by yourself. It's a self-learning study pack, right? I'm going to give you. If you join with the 2027 month of June and you follow the class accordingly. A gift I'm giving you because you're newcomers. So newcomers, I have to welcome you. So I'm giving you a small gift. So that is that. Okay. Shall we start then? You have your tute, right? I have sent the PDF. So under that, Lamai, there's something called alkanes, right? The topic alkanes under hydrocarbons. So hydrocarbons are compounds containing carbon and hydrogen. Hydrocarbons are compounds containing carbon and hydrogen. Can I erase the board now? Everyone done, right? ඇයි මම මේ ෆෝන් වල නම් වලින් join වෙන්නේ? Why are you joining with your phone's name? There is Oppo, there's an Oppo phone. හරිද? And there is a Greentel phone. හරිද? It's like a phone company. හරිද? It's like the Liberty Plaza. හරිද? Okay, whatever. So alkanes, right? Alkanes. What are alkanes? You have done this in your O levels, right? Under O levels, you had hydrocarbons, as I can remember. I can't remember O level now. It's a long time. So you had alkanes, alkenes, alkynes, as I can remember during your O levels. So alkanes are compounds containing carbon atoms and hydrogen atoms, and there are no double bonds or triple bonds in between the carbon atoms. Right? There are no double bonds or triple bonds in between the carbon atoms. Yes, carbon has only single bonds. For example, something like this. This is a 3 carbon containing organic compound. Now we can condense this and write it like this. CH3, CH2, CH3. We can condense this and write. We can condense this and write in papers. When doing conversions, you can condense this, and otherwise it will take a long time to write these compounds. So we're gonna write it like this. Write this down. In the tute, are a chute on the right hand side. Now this is something which is very common. You don't have to study this or anything. That's why I didn't give any space for this. If you want, you can write this down. Somewhere in the corner, you can write this down. Okay. Then Lamai, we have combustion. Combustion done now, Gati. You know about combustion. In energetics, you learned it. Right? In energetics, you learned it. In energetics, you learned it. What is combustion? For example, like let's say you are going to combust CH3, CH3, right? This is ethane. So you react with oxygen. Now, Lama, in inorganic, what you did was you wrote the reactants like this, and you balanced also, right? Hemadala, sodium chloride, and then H2O, and then if there is something to balance, and you balance it, that's how you write inorganic reactions. But in organic, you don't balance the reactions. You just write the reactant and the reagent that you're adding here. This is the reagent. This is the reagent which you're adding, right? And this is the reactant. This is the reactant, and then you're going to heat the mixture a little bit, and then you're going to get carbon dioxide and water. So this is called combustion, right? This is called combustion. Please write this down in your tute and raise your hands in your done. Harila, are you done? When you're finished, raise your hands. Hari, when you're finished, raise your hands. Mangara kiwana, you have to be active කියලා. Then ළමයි 5 දිනක් I removed from the class. I removed 5 students from the class. හරි මං අර I am not taking you just for money. හරි I'm not taking you just to get my monthly payment and then do some classes. එහෙම නෙමෙයි. If you are a student, you have to do the questions, you have to attend the classes, you have to respond to messages, you have to be like that. මම 5ක් අයින් කරා. 5 students I removed from the class. හරිද? And gave them a warning. 3 of them joined back and 2 of them I didn't take them back. හරිද? So එහෙම තමයි ඉන්න ඕනේ. You have to be very responsive in the class. When I ask questions, you have to answer. Interaction නැත්නම් otherwise it's boring online නේ ළමයි. This is online class. Online class එක I want to make it like a physical class. මේක physical class එකක් වගේ මට හදන්න ඕනේ. That's the point. Right, there are many students in Anuradhapura, Trincomalee areas where they don't have any physical classes. ඒ කට්ටිය මෙහෙන්න they can't come to Colombo, right? They can't come to Kandy even. Like it's too far. So I want to do this online. I'm doing this fully online. You have to give your maximum maximum support in order to do the class efficiently. You have to support me to the maximum. You have to be very talkative. I won't scold you if you are talkative, and if you ask doubts, I won't think that's a stupid doubt. I will never question your doubts. Harida, I will answer them, and then I will not mock you for your questions. Harida, I'm also like around 5 years older than you, maybe like 4 to 5 years older than you. I'm 2004, right? You guys are like 2008 or something. 4 to 5 years older. So, I'm not a. Will you give the tute when I join your physical class? There's no physical class. අපි online විතරයි කරන්නේ. If you have joined from the main 2027 theory group, මම ඒකට tute එක දැම්මේ නෑ. I didn't put the tute. So you can drop me a message in WhatsApp. I will send you the tute personally because I only send the tute for the students who replied to that message, and then I added them to a separate group, and then I sent the PDF for them. That if you want the PDF, you can drop me a message because I'm not sharing it to the outside. Message එකක්වත් දාන්න නැති කට්ටියට එහෙම දාන්න නැහැ tute එක. I'm not putting it like that. Okay, so combustion is done. This is combustion. So this can be done for alkenes and alkynes as well. Write a note there. Write a note with the red pen or blue pen or something. Now, if you don't have the tute ළමයි, you can write these things in A4 sheets. හරිද? A4 sheets වල ලියන්න. හරිද? After that, you can write this when you get your tute. If you make the payments like on Friday or Saturday, I'm sending your tute. So එතකොට ඔය කට්ටියට ගන්න පුළුවන්. හරිද? එතකොට you can write the reactions in the tute itself. For now, just write it in an A4 sheet. Make sure you definitely write it. You can write it later, right? Okay. Right there. Alkenes and alkynes also undergo combustion. Alkenes and alkynes. Alkenes and alkynes also undergo combustion. to form carbon dioxide and water. To form carbon dioxide and water. Right? To form carbon dioxide and water. Okay? Right. දැන් මේ after today's class දැන් මේ class එක ඉවර වුණාට පස්සේ I'm sending a revised paper. Revised paper කියන්නේ I'm going to give you some questions regarding today's class. අද class එකේ මම ඔයගොල්ලන්ට questions ටිකක් දෙනවා. You have to write the product or the reagent in those questions and then answer them. This is just to revise your knowledge. I'm not giving it today itself, not tomorrow. But after like 3 to 4 days, I'm going to give you to just revise you the knowledge, right? Revise what you have studied in the class. And then once every 2 weeks, I'm going to give you something called a battlefield paper. In the battlefield paper, what I do is I give you some essays, 1 to 2 essays, and a structured essay question to answer by yourself, right? What you have to do is you have to answer it, and I'm going to give a marking to you. I won't discuss that paper. I will give a marking to you. If you have any doubts, you can ask me, and I'm going to give a small discussion for you if you want. හරිද එහෙම කරන්න. එතකොට there's the main exam. So main exam is done once every month. The month end actually we are doing a main exam where now that paper will be marked and it will be discussed for you. Right? So that's the procedure of the class. Okay. I'm not doing physical in Kandy right now because I'm in Colombo. Okay, to form carbon dioxide and what? Carbon dioxide and water. Carbon dioxide and water. No, you're not balancing any reactions in organic. Organic wala balancing නෑ මං කිව්වනේ. There is no balancing in organic. When doing conversions, then normally ලියද්දී now in energetics and all, let's say you are writing a මේ conversion නෙමෙයි, a reaction. In energetics and all, if you want to do a calculation, then of course you balance it. Of course you have to balance it. මේක balance කරන්න ඕනේ. හරිද? But I'm telling when doing conversions and all, you don't have to මේ balance it and write the products. There is nothing called balancing in conversions. Hari? Okay, you will understand in another 30 or 40 minutes. You will understand this. Hari? Okay, second one is halogenation. You can read that part. Although alkanes do not react with common polar reagents. What are polar reagents? Polar reagents කියන්නේ compounds like HBr. Because they are polar, right? They are polar. Br contains a delta minus and this contains a delta plus. So these are like polar compounds. Polar compound. So they do not interact with any polar compounds. They tend to react with free radicals by homolytic cleavage of CH bonds. Then ඕක මොකක්ද කියලා අහන්න එපා. Now don't ask now what is that what is that even? ඒක දැන් ඉගෙන ගන්න නැහැ. හරිද? I have given it for you to refer it for future. Right? මං අර mechanisms කරද්දී I will teach you that. Right now what you have to understand is the reaction and the product. එච්චරයි. Trust me. Trust me here. Please trust me here. I will teach you this under mechanisms deeply. I will go too much deep into this and I'll teach you everything under this, under mechanisms. Mechanisms කරද්දී we are actually revising these things again. So, ඒක එතකොට බලමු. So you can read that part. Right? For example, alkanes react with reagents such as chlorine and bromine free radicals, Cl and Fbr atoms, which can generate by homolytic cleavage of Cl2 and Br2. This can be achieved by irradiation of Cl2 or Br2 with ultraviolet radiation. Thus, methane in the presence of ultraviolet light reacts with Cl2 to give a mixture of chloromethanes. Now, this is what's happening. This is all what you have to know. CH4, let's say you react with chlorine, and you have to write something like this, H mu. You call this H mu. This shows that you are holding the reaction container into sunlight. You have to put it under sunlight, then only the reaction will happen. Right? You have to hold it under sunlight. You write it like this, Cl2H mu. You have to definitely write it. Cl2H mu. So the products would be CH3Cl, where like one hydrogen atom is replaced by chlorine, right? Make a hydrogen atom you're replacing with a chlorine. So this can be one product. This can be one product. Also, there can be another product, CH2Cl2. You can replace two hydrogens, right? You can replace two hydrogens. So that is also a product. You can also have CHCl3. You can replace three hydrogens with chlorine. And then you can add 4 chlorines, CCl4. So these are the products which you can obtain through this reaction. And they have a concentration order. The major compound. The major compound is this one. That's the product. Like, let's say, like 100 CH4 molecules will react. This one will form around 60. This one will form around 30. Right? This one will form around 5. This one will form around let's say like 20. Right? 20. And then this is 15 and this is 5. Something like that. So the concentration order will change like this. CH3 Cl is the one with the major product. That's the most forming product. And then you have CH2 Cl2, and then you have CHCl3, and then CCl4. Write this in your note. Hari? Okay. There is a good thing I have to tell. Both of these reactions which we learned cannot be included in conversions. හරිද මේ දෙකම conversions වලට දාන්න බෑ. You cannot put these in conversions. What is the reason? What is the reason why you can't put this in conversions? I'll teach you in a while. Please write this and raise your hands when you're done. Okay? Raise your hands when you're done. Under halogenation, under halogenation only you can write this. You can write this reaction and the products, put commas and put the products, and then below you can write the decreasing order. Right? This one will be the major product. Then this, then this, then that. Okay. Then comes the most important one. Now only the real organic reactions start. Alkenes. Hurry. Now we are starting alkenes, and this is the place where we learn. I lost connection, so can you explain it again? Which part do you want me to explain? Shakina? Which part do you want me to explain? Halogenation. Halogenation, okay. So in halogenation, Shakina, this is what happens. So there is something called CH4, that one carbon with 4 hydrogens. So you have seen this in unit number 2 also, you have seen this. You react this with something like Cl2, chlorine gas. You can also react with Br2, right? Br2 also will react. So what is this? This is called H mu. Again, H mu, you read it like H mu. You write the hydrogen name, sorry, H. And then you put a symbol like this. Mu, you call this mu. So this is like E is equal to H mu. H mu can HF. Harina. This is HF. So this is a energy of 1 photon, right? That is why we represent like this. Now when you go to university and everything, we don't use F. Frequency F, we're using mu. H mu. So this is what we write here. Cl2 H mu. Cl2 H mu. The products are CH3Cl, CH2Cl2, CHCl3, and CCl4. And like what's happening? The hydrogen is getting replaced by a chlorine. You remove the hydrogen, you add a chlorine. Right? You remove the hydrogen, you add a chlorine. Are you done? Did you understand? Okay, good. Ask doubts, ask questions. If you didn't understand, tell me. Right? That is the type of students I want, especially in a theory class. Hurry, alkenes. Alkenes are hydrocarbons which contain a double bond between the carbon atoms. For example, CH3, CH, and you have a double bond here, and then another 2 hydrogens. So when you put a double bond here, you have to remove two hydrogens, right? That's something which is known by Lewis structures. You have drawn Lewis structures before, so you can't exceed the octet. So you can't draw something like this. That is wrong. So there's a lot of students, even 2026 students, who can't write a product like this. What they do is they write it like this. They don't know how to use the octet rule. CH3. This is wrong. There are only two hydrogens here. One hydrogen there. What they are writing is like this. This is wrong. This is wrong, right? So you have to put only one hydrogen there, and here only two hydrogens. So that is what happens. You have two hydrogens here with the carbon, and this is one hydrogen with the carbon. Right? That's how it happens. Okay. So this is how you condense and write. This is how you condense and write. Okay, I'm erasing the board now. Okay, I'm erasing the board. Right. So then the first reaction of alkene, hydrogenation. So when you read that word, what will you understand? Hydrogenation. Hydrogen react, like we are reacting it with hydrogen. So we are adding hydrogen into the compound. So I will tell you a shortcut to remember. My shortcut is here. So CH3 is CH double bond CH2. So what is the compound which you are reacting? Hydrogen, right? Now, what you're going to do is, if you want to add hydrogen into this, what you have to do? You have to break the bond. I'm erasing the bond. Then I'm breaking this bond in half. So you have two hydrogens like this. Two hydrogens like that. I'm going to attach one hydrogen into this. Attach one hydrogen into this. That is the product of hydrogenation. Right? So you will get an alkane. CH2, CH3. Okay, that's easy, right? So this is how the reaction happens. You react with hydrogen and you get an alkane. But this is not all. You have to remember something else. You have to remember something else. You also have to remember a catalyst, because this reaction is too slow. There is something called catalyst. What are catalysts? What are catalysts? What are catalysts? Does anyone know what are catalysts? Does anyone have an idea about what are catalysts? Catalysts are compounds which increase the rate of the reaction. So let's say like a reaction is taking 1 hour to finish. There's a reaction which takes 1 hour to finish. And you're going to add a catalyst into it. You're going to add a catalyst into it, and the reaction now happens within like 5 minutes or something, right? Within like 5 minutes, the reaction happens. So those kind of compounds, you call them as catalysts. They increase the rate of the reaction without getting used up. Very good, right? They increase the rate of the reaction without getting used up. So bio students, you had an idea about this, right? In the unit number 2, where you learn about enzymes. Enzymes also act as catalysts, right? So can you explain back after the halogenation? After the halogenation, after halogenation, I didn't do anything. Listen to this, what I'm telling, okay? Hurry. Okay. So listen to what I'm telling. So you're going to react an alkene with hydrogen. That is what is happening in this. So there you can see in the note I have given you possible catalysts. So these are the catalysts which you can add into this reaction. You can add nickel. Nickel Nickel is a D block element which can be used as a catalyst. Rainy nickel. What is rainy nickel? And that one you need to understand. So rainy nickel is something like this. So you have aluminium. You have aluminium and nickel alloy. Nickel aluminium alloy is there, right? So this is aluminium and this is nickel. You call this nickel aluminium alloy. You have nickel aluminium alloy. What you're going to do is you're going to add sodium hydroxide into this. You're going to add sodium hydroxide into this, and now what will happen? Aluminium will dissolve. Aluminium will dissolve away, and now you will get something like this with a larger surface area. Now this one has a larger surface area. Right? This has a larger surface area. Now this is rainy nickel. You call this as rainy nickel. So the catalytic effect of rainy nickel is larger than the catalytic effect of normal nickel. Rainy nickel ge catalytic effect එක වැඩි. Why is that? Because the surface area is now larger. Surface area is elevated, so therefore the reactivity is larger. Okay, the reactivity is larger. If you can, please write this in the tute. Podiat liyanna, write it very small. So the class students, one of you should send me the note today. අද එක්කෙනෙක් මට note එක දාන්න. One of you can send me the note because the newcomers who join to the class, if they want to fill the tute, right? So I will send your tute to them. එක්කෙනෙක් මට එවන්න. One of the class students send me the tute after the class. Okay? හරි. Raise your hands when you are done drawing this. So rainy nickel means the nickel, you have increased the surface area. Right? You have increased the surface area of nickel. That is the thing. Okay? So these are normal existing in the world. මේ වගේව තියෙනවා. Nickel, aluminium, alloys are there. Right? Okay. Done? Hurry. So let's write a reaction. So let's write a reaction. අපි ලියමු for this compound CH3CH double bond CH2. So what you're going to do, you're going to write hydrogen here. මෙතන ලියන්න නැහැ, like මෙහෙ ලියන්න නැහැ. When you are doing a conversion ළමයි, we are writing an arrow and then on top of the arrow we are going to write the reagent that you are adding. And then you can put a slash, right? You can put a slash and then write the catalyst. Let's say you're putting platinum here. Platinum also can be added, right? You have to write the reagent and this is the catalyst. Catalyst, this is the reagent, right? This is the AND symbol. Hari, this is not the O symbol, this is the AND symbol. Now, sometimes you write it like in inorganic and all, you write it like this aluminium O zinc. In organic, it's the other way around. In organic, like this shows the AND symbol. With hydrogen, you are adding platinum. Both you have to add. Not only one, you have to add both. Okay. So this is the AND symbol, this is the catalyst, and this is the reagent. So when you add all these together, you will get CH3, CH2, CH3. Like the alkene will be converted to an alkane. So the reaction I told you, hydrogen will break its bond and then one hydrogen will attach here, other hydrogen will attach here. A carbon they attach and then you get the product. Okay. Hurry. Write this down and raise your hands when you're done. You can write this in your tute. Okay. Lamai me. I will tell you something me regarding the Pomodoro technique. If anyone have heard about the Pomodoro technique, raise your hands. If you have heard about the Pomodoro technique of studying, raise your hands. Pomodoro technique, if you know that, raise your hands. 9, 10 students. Hari, okay, fine. So rest of the 20 students don't know, right? Hari, mehemai. Now in Pomodoro, this is what happens. Now normally our brain, its efficiency decreases largely. When let's say you're studying like this, you're studying and your efficiency, normally like it will take like this and then it will drop down. It will drop down, right? With time, the efficiency drops down. Efficiency drops down mean like you will be drained and you will not be able to study for a long amount of time when you study continuously, right? When you study continuously, that's not possible. But now what we are doing is we are studying for a short time interval and then we are going to have a 5 minutes break. Not a 10 minutes break. You can't go to the neighbor's house and then play and come back and then say that. That's not going to work. I'm telling you, study for 25 minutes. Study for 25 minutes and then have a 5 minutes break. This is the normal Pomodoro. This is what you see in YouTube. But I'm going to modify this a little bit. Because it works for me. So what I am doing is I'm going to study for 25 minutes. Then I'm going to take 5 minutes to revise what I have studied. I take 5 minutes to revise what I have studied before. I'm going to revise. For that 25 minutes, what did I read? Like some people, they just read the resource book, read the bio resource book and don't know even what they have read. That's the problem. right? So I am going to revise what I have studied in that 25 minutes within 5 minutes. Vinadi pahak kadra I'm going to revise that point. And then I take the break. Then I take the 5 minutes break, and then like within 35 minutes, your first Pomodoro is over. Then you can start again. There are apps for this. How is the Pomodoro apps? There's something called Forest app. You can download it. You can plant trees. You can set a time for 25 minutes, and then you can study. How is the apps? I won't promote them, but you can do this alone. Just time yourself for 20 minutes, and then 25 minutes, and then keep 5 minutes for revising purposes, and then another 5 minutes you can what you call have a rest, and then start again. You can do like 2 to 3 pomodoros, right? 2 to 3 pomodoros, and then have a long break, like 30 minutes or 20 minutes, and then you can like have a wash and then come back. And like you know how to study, right? You can continue it like that. We're going to do the class also like this. Class your learning capacity increases when you have a short break, right? So since we did the class for 45 minutes now, have a 10 minutes break. So within this 10 minutes, do not take your phone. No phones. No screens. No phones. No screens. Not even your laptop. Don't stay looking at your laptop. Just look somewhere else. Just if you can like go out. It's night already. You can't go out. Okay, fine. Just walk around and come back within 10 minutes. At 7:54, I'm going to start again. Right? Now the time come by 7:54. Do not lose this time. Had vinadi the high break here. You can't look at screens or phones. Okay? Right. Okay, Lamai, are you there in the meeting? It's 7:54. I told you not to miss the time. Raise your hands if you're there in the meeting. Okay, good. Right. So we did reactions of alkenes, hydrogenation. So we wrote one reaction under it. Then the next one is halogenation. The halogenation is also something similar. Now, halogenation, Lamai, the reaction medium is CCl4. Now, when you're writing Cl2 there, when you're writing the reaction, for example, CH3, CH, double bond, CH2. In this case, when you reacted Cl2 in the presence of CCl4, මේක CCl4. හරි දැන් ඉස්සෙල්ලා අර HMU කියලා දැම්මේ. We put HMU right for alkanes. This is alkenes, so we are adding Cl2 in the presence of CCl4. So CCl4 is not very necessary, but it's good if you can write it because that's the reaction medium. That is what you dissolve Cl2 in. So what happens? Just like the previous case, as I told you, the bond breaks in middle and this one gets erased and this one gets attached here, this one gets attached here. So you will get a compound with two halogens attached. Right? You will get a compound with two halogens attached. So you will get a product like this, CH3CH, CH2, Cl and Cl. Hari? Cl දෙකක් attached now, like that. Okay, so let's write another reaction where we have something like this, CH3C, CH3, double bond, CH2. So for this compound, let's say we had Br2 in the presence of CCl4. Now the product, Br will attach here, Br will attach here. CH2 and Br. So two Brs will attach to the two carbon atoms. So write these two reactions in your note and raise your hands when you're done. Hurry. Not hard to remember. You have to revise every week. Hurry. Revise because there are around 50 reactions you have to learn. In all organic. That's why we take 5 classes to complete. There's a lot of reactions you need to understand. So Lamai may revise every week. Do not try to forget these things. Hari may ඔක්කොම හැමදාම revise කරන්න. So I will make sure you do conversions within like 2 months. හරිද? මම මාස දෙකක් යන්න කලින් I'll practice making you better in conversions, which most of the students struggle around for 5 to 6 months. At least like 90% of students will do conversions after 2 months if you work. Hari? Hari. Then Namai, the next one is hydrohalogenation. Now we learned hydrogenation, we learned halogenation. Hydrohalogenation කියන්නේ මොකද්ද? It's like hydrogen and chlorine you add together. So you add HCl. තේරෙනව නේද? You're adding HCl. Hydrogen and bromine together, HBr. Do you understand what I'm telling? Hydrogen and iodine, HI, right? So these are called hydrohalogenation. This is called hydrohalogenation. So this happens according to something called Markovnikov rule. Don't even try to remember that. Like for now, you don't need it. I told you, right? First of all, we are doing reactions and then later we are doing mechanisms and I'm going to teach you those things. Then you have to learn hydrohalogenation, only the product. And I will tell you a shortcut to remember. Okay. So this is, you can read that part, reacting an alkene with HBr or HCl. The Br atom or Cl atom will attach to the central part of the molecule. This will be learned deeper under mechanisms. For now, knowing that the Br atom attaches to the innermost carbon will be enough. For now, this is only important. CH3, CH, double bond, CH2. Lamai, when you add HBr into this, the Br will attach to the central carbon, right? Br will attach to the central carbon and for the terminal carbon, the remaining hydrogen will attach. The remaining hydrogen, the HBr, one hydrogen will attach. Now it's like this. Br will attach to this, hydrogen will attach to this. So you have the product. And the product is that. So hydrogen will attach to the terminal carbon. So you write it like this, CH3. So this is the product. And how to remember this? මේක මතක තියාගන්නේ කොහොමද? හරි. So how to remember this? Now ළමයි BR is there. I will write a statement. BR is shy. Do not forget this. BR is shy. BR නෙමෙයි halogens are shy. Halogens are also shy. OH is also shy. You will learn that later. Like most of these compounds are very shy, lamai. They don't want to get exposed to the outside world. They don't want to get exposed by attaching to the terminal. Now, if it attaches to the terminal, lamai, look at this value. If it attaches to the terminal, it will be exposed to outside, right? It's not good. I mean, BR is shy, so it likes to attach to the central carbon. It attaches to the central carbon. Central carbon eකට තමයි attach වෙන්නේ. That's the point. හරි? Central carbon එකට තමයි attach වෙන්නේ. But there's another reaction which you learn later. Hydrohalogenation type 2. ඒකෙදි this turns other round, right? Turns other way around. Now for example, let's say this compound. Let's say we have this compound CH3, CH2, CH3. Double bond CH, CH2. Now when you attach, let's say HCl this time, I won't put the same thing. Then HCl damn again. Now tell me where does the chlorine attach? Number 1 or number 2? Carbon number 1 or carbon number 2? Tell me. Drop a message. Carbon number 1 or carbon number 2? To which place does the chlorine attach? Carbon number 1 or 2? Message done, come on. Hammer again. Come on, everyone. Quickly. Nice. So, any uttar? Okay. 1. 1. 1. Right? Okay, 2. 2. Anyone else? 2. 2. Okay, Hamna. Masha, Anas, 2, okay. 1. Lena, carbon 1. Hurry. Then metana ඇතුලෙන් ඉන්නේ කවුද? Now look, the second carbon. This carbon is surrounded by 2 carbons, right? One on the left hand side, one on the right hand side. This carbon is surrounded by 3 carbons. This one, and this one. Surrounded by 3 carbons. This is surrounded by 2 carbons. Right? This is surrounded by 2 carbons. This is surrounded by 3 carbons. මේ පැත්තේ එකයි, මේ පැත්තේ එකයි, මේ පැත්තේ එකයි. So Cl atom will attach to the innermost carbon. මෙන්න මේකට තමයි attach වෙන්නේ. It will attach to the innermost carbon. So now the product will be the chlorine attached to carbon number 1. Right? CH3, CH2, CH3, chlorine, CH2, CH3. Oh no, what am I product? That's the product. Hurry. That is the product. Okay, Shiva Gomez. Please raise your hands once you're done writing this. Okay. Take a rough worksheet, Lamai. Take a rough worksheet. Take a rough worksheet. Take a rough worksheet. Okay. So I want to write the product of this. I wanted to write the product of this. Number 1. CH3, CH2, CH3, double bond, CH2, CH2, CH3, CH2, CH3. So you're going to react this with HBr. So you tell me, to which carbon does the Br attach? 1 or 2? Drop a message under the chat everyone. Or everyone කියලා තියෙන්නේ. අන්න ඒකේ chat එකක් දාන්න. Okay, now you can message under everyone. Zoom there is something called everyone. So you can send the message to everyone. So it's easier for me. I don't have to select one by one. So you tell me, to which carbon does it attach? 1 or 2? Please send your answers. Everyone, come on. Done. 1, 2, 2, 1. Okay, others? Kiana, it's a 50-50 probability. Even if you get it wrong, it's fine. 1. 1 the 2 the 1 the 2 the. Is it 1 or 2? There is like equal amount of people telling either way. 1. Hurry. 1. Okay, lamai. Mehemai. Now we have to compare. Make a compare කරන්න ඕනේ. Now look at the neighbors. Now there are 3 carbons for this carbon, and this carbon. There are 3 carbons. මෙයාටත් ඉන්නවනේ 1, 2 and 3 carbons. So that's fine. Now there are 3 carbons. The next thing what we check is the length of the carbon chain. ඊළඟට බලනවා length එක. දැන් මෙයාගේ length එක only 1 carbon. ඒ කියන්නේ carbon atoms also it should be larger. The carbon number which is attaching should be large. Then only it will get more protection, right? Now Br is shiny as I told you, so it needs more protection. Then ගොඩක් කට්ටියදී හොඳයිනේ. Now there are මෙතන දෙන්නෙක් ඉන්නවා. There are 2 bodyguards. Here there are 3 bodyguards. හරිද? So it's more safer in 2, right? මේක ලොකු chemistry වලින් හිතන්න ඕනේ නැහැ. There is nothing to think in chemistry. Just normal logic. I told you Br is shy. If Br has more protection, then it will go there, right? මෙතන safe. This is more safer. There are 3 plus 1, 3 plus 2, 5 carbons are there surrounding. But in this case, there is only 2 here and there's only 1 here. Madine, not enough. So Br, what it decides to go to the number 2. It will go and attach to number 2. So CH3, C, CH2, CH3. Hydrogen will attach here and the carbon, bromine will attach to this carbon and then you have the rest of the compound. CH2, CH2, CH3 and you have CH2, CH3. හරි Br එක attach වෙන්නේ මෙන්න මේ second carbon ට. It will attach to the second carbon. Okay. So does that mean that bromine will never attach to this one? No, it will also attach. Actually 2 products are obtained. Major product is this one. The other one will be a minor product. So I will teach that deeply under mechanisms. One I'll teach you that in mechanisms. So the other compound will be a minor product. So Lama, you don't know 100% from this theory. This is just an overview. I told you, right? We are touching the grass. We are just touching the grass and going. There are compounds like this. Mehema compounds, where you have a benzene ring. Right? You have a benzene ring and the story changes. The story changes here. Here the bromine will not attach here. It will attach here. ඒක ලොකු ස්ටෝරියක්. Like we are going to learn this under carbocation stability. You need carbocation stability in order to write the products of compounds like this. ඒවා අපි පස්සේ කරන්න. For now, just know the normal reaction. Like this, I will teach you carbocation stability when we are going little bit more further. හරිද? තව ටිකක් ඉස්සරහට once you do alcohols and maybe like benzene and all, after I'll teach you carbocation stability. හරි. Okay, right? Then take the tute. Take the tute. Then go to number 4, hydrohalogenation type number 2. Hydrohalogenation type number 2. Yeah, when the carbon length increases, right? When the carbon length increases, carbon chain length increases, what happens? There is more protection, right? The BR is like, I told you, right? It's very shy. So when it's surrounded by a lot of carbon atoms, it likes to go there. Right? It likes to go there. It's like a girl, Lamai. BR is like a girl, not only BR. CL is also like a girl. And, iodine is also like a girl. Like, they're very shy. Dannane. Okay. So the next one is hydrohalogenation type number 2. මෙතන මොකද වෙන්නේ? CH3CH, CH2, and you react HBr in the presence of a peroxide. In the presence of a peroxide. Peroxide එකක් දැම්මහම now what will happen? ළමයි, if a girl is shy, if the girl stays with her father, then she is not shy, right? I mean, if that's the father for her protection, she's not shy anymore. She's okay to go out to the world and face the world, right? So they will become normal. This is the effect of H2O2. When H2O2 is there, Br is not shy anymore. Br is not shy anymore with the presence of H2O2. With the presence of H2O2, Br is not shy anymore. Now the Br will attach to the terminal carbon. It can attach to the terminal carbon. So your product will be like this. Your product will be that. You got it right? Your product will be that. Okay. So it's the other way around. The theory other way around. So for HCl, does it work the same way? If you put HCl, make it up, put HCl value, HCl in the presence of H2O2. Now what will happen? Cl is shy anyways. There are some girls, even if the father is there, they are still shy. They are still introverts. They don't even speak a word. Like some people are there, like they don't even speak a word. None your friends are there, some friends. Cl is like that. Cl is even shy, even with the presence of the father. Right? She will never talk. Right? She'll never talk in her life. She can never attach to the terminal carbon. She can never attach to the terminal carbon. Chlorine is never possible of doing that. Even if you had H2O2, nothing like that will happen. So CH3, CH, Cl and CH3 is the product. So even though you add H2O2, it has no effect. So you don't add H2O2 normally. Like useless. It only works for HBr. Right? It only works for HBr. It does not work for what you call HCl. Hari BR is shy anyways. I write it in the tute. Write it in the tute. BR is shy. BR is not shy in the presence of H2O2. Cl is shy anyways. Write these things in the note. It's fine. It's something which you study, right? So no issues. Right, so you can read that part. We can reverse attack the previous reaction by adding a peroxide, H2O2 or R2O2. R2O2 what is R2O2? So R2O2 looks something like this. What is R? R කියන්නේ alkyl group එකක්. It's an alkyl group. Alkyl group it can be something like CH3 or CH3. Or it can be a long carbon chain. It should contain this part. This part should be there included. Right? This part should be there included. Hurry. Okay. Done writing? Raise your hands if you're done. You guys are very good. Still, there are 33 members in the meeting. However, still the initial amount is there. Actually, like 3 or 4 reduced. You guys are very good. Again, like you are attentive when you're listening to the class and you don't find it boring. So that's good. Okay, then the fifth one is hydration. Fifth one is hydration. Hydration කියන්නේ මොකද්ද? Hydration. Now we learned hydrogenation, halogenation, hydrohalogenation type 1, hydrohalogenation type 2, and now we have hydration. Hydration, by the word, it means like adding water, right? Yeah, this is about adding water. So this is about adding water, but water will not react. Water react karanna, you have to add an acid. You have to add H2SO4. Right? You have to add H2SO4. It'll make a reaction, nigga. So you can read that part. Addition of concentrated sulfuric followed by hydration, adding water for alkene. The OH minus will attach to the centermost carbon atom. So first of all, there is this compound CH3, CH and CH2. So here also it will attach to the centermost carbon atom. Like OH will attach to the centermost carbon atom. So OH is shy. Write it. OH is shy anyways. There is no way you can attach the OH to the terminal carbon. You can't do that. Okay, write the product. You're first of all adding concentrated H2SO4. So you write conc H2SO4. This is how you write the reaction. Conc H2SO4. So when you add conc H2SO4 into this without adding water, you're going to get a weird compound. Trust me, you will understand this. Sorry. You're getting a weird compound. So H2SO4 molecule I can draw like this. This is the H2SO4 molecule. Sorry. That's the hydration here. This is the H2SO4 molecule, right? So the bond is breaking from here. From here the bond is breaking. Right? From here the bond is breaking. And you're attaching this oxygen to this carbon. This hydrogen you attach into this carbon. Right? So now this whole compound, think of this as a flower. The oxygen attach karna. Think of this as a flower. හරි මේක නිකන් flower එකක් කියලා හිතන්න ඕනේ. මේක ගිහිල්ලා මෙහෙම යටින් attach වෙනවා. So your product CH3 CHO and you have the flower. හරි. You have the flower and then you have the CH3. The hydrogen will attach to this carbon. So you have this compound. How do you write that? You can't write this in the exam. So what you do? You short form. You write it in short form. You attach the carbon to the oxygen. You attach the carbon to the oxygen and the rest of the molecule, count it. There is one sulfur. So you write it there. You write it there. And the 3 oxygens, 1, 2, 3, O3, right? OSO3. And the hydrogen remaining one, I write it as H. OSO3H. This is the product which you obtain when you add concentrated H2SO4. So write that in the note. And then after that, Lamai, we are going to add water. It was Abhidhana water. Now what happens? This whole thing converts to an OH group. So you have CH3, CH3, and OH. Right? You have CH3, CH3, and OH. Okay? So you have this product. No. You can't write O4SO3 because the oxygen is attached to sulfur. The oxygen card attached, you have to show it. Otherwise, the compound will differ, right? You have to write it like that. Maybe write it like this. So please draw this. Like it's good to understand. Draw this. Then there's a statement given below. The above steps can be combined together and we can write directly dilute H2SO4. The concentrated H2SO4, when you mix with water, it's dilute H2SO4, right? So you can write dilute H2SO4 and go directly from this to that. Right? Okay, I'll explain the reaction once again. So you have this alkene එක තියෙනවා. You react with conc H2SO4. So what is this big compound? This is H2SO4 Lewis structure, right? So what happens is this bond will break in half. The hydrogen will go and attach to the terminal carbon, and the oxygen here will go and attach to the innermost carbon, just like the HBr reaction. Br will attach to the innermost carbon, right? This big thing will attach to the innermost carbon as well. So this is like an elephant, right? This is like an elephant. Elephant will attach to the center. So I drew this cloud-like thing to show you that this whole thing is just SO3H. I have condensed it and written like this, right? Make condensed color. So you will attach this whole thing to the innermost carbon, and then you are adding water into this. And now what will happen? It will convert to an OH. Right? It will convert to an OH. As a byproduct, Lama, you are getting H2SO4. As a byproduct of the reaction, you are getting H2SO4. So you can see H2SO4 is acting like a catalyst. Right? H2SO4 is acting like a catalyst. Initially, you had H2SO4. At last, also, you get H2SO4. So it is acting like a catalyst. So what does H2SO4 does? H2SO4 allows water to get added into the compound. The normal water reactor, it won't react. It won't react just with water. Nikam වතුර දැම්මට it won't react. CH3, CH, OH and CH3. මෙහෙම වෙන්නේ නැහැ. This will not happen. එහෙම වෙන්නේ නැහැ. You have to add H2SO4 and then only you have to add water. Then only it will react. Got it, right? So you can write this. So if we raise your hand if you finish writing this. Wait, I'll write it in the next one. That's what I told now. When you combine these two together, you will get dilute H2SO4, right? So dilute H2SO4 also will react the same. So I'll write it in the next one. So in your tute, you have it. Look at the PDF, Lamai. The above steps can be combined together and we can write dilute H2SO4 directly. One more thing, you're getting a short note. With the tute, you're getting a short note. Or short note you don't want to make short notes. You're getting a short note from us for all the organic reactions in the syllabus. We are giving you a short note itself for all the reactions of organic with your courier tute pack once you enroll with the class. Hurry. Then may steps combine we can combine the steps together, right? CH3, CH, double bond, CH2. So you're adding dilute H2SO4. Are they combine karna? Conc H2SO4 plus water is dilute H2SO4, right? So this one also same thing happens. So you get the product CH3, CH, CH3, and OH. Directly you can write the product. Right? You can write it like this. Or you can write it like this also. So how is the HO bond in H2SO4 broken? Mechanisms. I told you, right? We are not going deep into the reaction mechanism. If you want, I'll send it to you privately in WhatsApp. I will not teach this in the class right now. I'll teach you this later. Hurry. So what happens is, because there are students who are like curiously like normal like they are trying to finish the syllabus within 1 year and then like write the exam and get a rank. Not the average students, but like better than average rankers la. So those are the people may like that. So you can write this reaction like this also. I'll write it to the same compound. You can write it like this. You can put number 1, Roman number 1, and write conc H2SO4. You don't have to write dilute H2SO4. You can write it like this as well. This is also another method. So number 1 conc H2SO4 and then you get number 2 and water. You can write it like this. Conc H2SO4 and water. Okay, conch H2SO4 and water. Okay, Lamai. Done, right? Now have a 5 minutes break. Pinadi Bahai, no phones. Hurry. No phones, no screens. Just stay without the screen. Hurry. Have some breath, like breathe in, breathe out, and you know, right? I mean, just relax for 5 minutes. I will start at 8:29. 8:29, be in the class. Okay. Instead of numbering, can we put slash? You can put slash, but the thing is like you're adding first conch H2SO4 and then only you're adding water. ඉස්සෙල්ලා H2S මේ කොන්ක H2S දාලා තමයි you have to add water. That's how we are doing it. Yes, we get the same product. That's the beauty of organic. Right? You don't have to balance the reaction. You just have to write the reagent and product. That's it. Okay. Then next one, Lamai, the final type of reaction. The final type of reaction, oxidation in basic medium. Right? Oxidation in basic medium. Alkenes react with cold alkaline dilute KMnO4. Another cold alkaline dilute KMnO4 permanganate, potassium permanganate. Solution to produce diols. Diols can something like this. I will show you in a while. When this reaction takes place, the purple color of the permanganate disappears and a brown precipitate MnO2 is formed. Here, alkene undergoes oxidation and KMnO4 undergoes reduction. So this is a redox reaction that is happening here, right? So next one, you have a point in the next page. Oxidation in acidic medium is removed from the current syllabus. We'll give this reaction at the end of the tune separately. Now, oxidation in acidic medium, you will see some teachers will give you that reaction. But it is removed from the syllabus. They are not asking it in the A-level paper. But just in case if they ask, I'm going to teach you it at the end. Then at the end of the tune, you have special reactions. Special notes and reactions. There I'm going to teach you the stuff coming under that. So, oxidation in the basic medium is dilute KMnO4, which is alkaline and cold. So, it react right like this. So, CH3, CH, double bond, CH2, and you're going to add cold dilute KMnO4. So, you can add like මෙහෙම දාන්න පුළුවන්. If you want, you can write it like this, OH minus KMnO4. That works. Right? So if you want, you can write it like this also. It's going to be a better answer, cold and dilute. Right? Cold and dilute conditions. You are adding OH minus KMnO4. Basic medium KMnO4. Now the product looks a bit weird. Looks a bit weird. What's going to happen is OH will attach to this carbon and another OH will attach to this carbon. So that is called as a diol, or you call it as a glycol. CH2, OH, and OH. There you go. So this is called as a diol. You call this as a diol, right? You call this as a diol. You call that as a diol. So you will get a MnO2 precipitate in the basic medium. That is what is formed. MnO2 is a brown color precipitate, right? So in conversions, you don't write this. You don't write MnO2. You just write only this product. So you have this, you have that. Okay? Hurry. Just hold on. 30 minutes more to 9. Hurry. Hold on until 9. Hurry. What's that diol part? Diol කියන්නේ මෙතන OH දෙකක් තියෙනවා. Two OH atoms attached to two carbon atoms. Two neighboring carbon atoms. You call that as a diol. That is what is formed through this reaction. Write this in the note. Hurry. So how to OH minus? That is what is happening now in the basic medium when you like oxidize this compound. This is the product. Now here we cannot explain it in any way like how this is formed. Even there is no mechanism for this. This is what is formed when you oxidize. Oxidize කරාම මේක හැදෙනවා. Right? Can you say it again? Okay, there is the alkene. So you add OH minus KMnO4 in the cold and dilute conditions, and then you get this product CH3, CH, and Cl2, and two OH is attached into the neighboring carbons. So when you have two OH attached into neighboring carbons like this, you call that as a diol, right? You call that as a diol. And you will get a MnO2 precipitate, which is brown color. In conversions, you don't have to write this MnO2. I just gave it for your observation. So this is a method of identification. Right? When you add OH minus KMnO4, if you get a brown color precipitate, it's an alkene. Right? It's an alkene. Alkynes also react. I'll teach you that later. So this is the reaction. Write this and raise your hands when you're done. Hurry. Okay, Lamai. Next one. Next one we have alkynes. Hurry. Next one we have alkynes. So alkynes is a compound containing triple bond in between the carbon atoms. Right? Triple bond in between the carbon atoms. So first one you have reactions of alkynes. The first one is hydrogenation. Reacting alkynes with hydrogen in the presence of catalyst gives alkane. So you have the nickel catalyst as same as the previous one. Radium nickel also there is there. Palladium also there. Platinum is also there. And there's something called Lindlar's catalyst. I'll teach you that in a while. That is underlined, right? Ek underline කරලා නේද තියෙන්නේ. So I'll teach you that in a while. So other catalyst, when you react, you will get an alkane. But when you put Lindlar's catalyst, the alkyne will only go to an alkene. If you want to stop the reaction at an alkene, you have to add Lindlar's catalyst. So you can read after that. During this reaction, the alkyne is first reduced to alkene, which is further reduced to alkane under the reaction conditions. So normally what happens is the alkyne, when you put hydrogen lamine, it'll first of all go to alkene, and then after that only it'll go to alkane. After that only it'll go to alkane. Do you understand that? After that only it'll go to an alkane. මේකට ගිහිල්ලා ඊට පස්සේ මේකට එන්නේ. Right? ඊට පස්සේ මේකට එන්නේ. According to the catalyst which you are adding, this is stopping the second one. Now, if you add only Lindlar's catalyst, if you add Lindlar's catalyst together with hydrogen, you will stop in this compound. But when you add nickel or radium nickel or whatever it is, you're going to go directly from this compound to this. There is no stopping in middle. It's a very strong catalyst. Now, Lindlar's catalyst is a specially prepared catalyst. It's a specially prepared catalyst. I'll teach you that in a while. So you can read this part. The reaction can be stopped at the alkene. Only the first step. We are doing only the first step, right? By using a less active catalyst. Very often, palladium catalyst deposited on barium sulfate, deactivated by quinoline or poisoned by quinoline is used. This mixture of catalyst and deactivators is called Lindlar's catalyst. So Lindlar's catalyst consists of three things. There's palladium, there's quinoline, and there's barium sulfate. During questions, we should write all three of the above. Writing Lindlar's catalyst is not sufficient. So in the exam, Lamai, if you just write Lindlar's catalyst, it will not give you marks, right? You have to write everything. For example, you have to write all the three compounds which are adding. Let's say like CH3C triple bond. And you have an alkyne like this. So when you write in the compounds, you write hydrogen, palladium, and bottom of the arrow, you can write the rest. Quinoline, barium sulfate. So you write everything. Hydrogen, palladium, quinoline, and barium sulfate. And now, what is the product? It's an alkene. It will stop at an alkene. It will stop in a double bond. Right? It will stop in a double bond. The reaction will stop in a double bond. That is what's happening. So we are focusing only on this point. Other carbons, nothing changes. Right? Nothing changes in other carbons. This is what you are focused on. Hydrogen, palladium, quinoline, barium sulfate. So you get the product like that. So let's say like we have a compound like this. CH3, CH3, C triple bond carbon hydrogen. Now let's say like this. CH double bond CH2. And to this compound, let's say you are adding hydrogen, palladium, quinoline, barium sulfate. Hydrogen, palladium, quinoline and barium sulfate. Right? Hydrogen, palladium, quinoline, barium sulfate. So if you add into this compound, the alkyne will go to alkene and nothing will happen to the double bond. So double bond cannot be reduced to an alkane by using Lindlas, right? So it will not go to any other compound. It will go to this compound, right? Okay, this is the product. Write these two in the note. Good students. So let's write another example. Now, Lamai, other than this palladium, you can't use platinum. If you use platinum, then it will not stop in an alkene. It will go directly. You have to use palladium, quinoline, barium sulfate. You cannot use anything else. Hari? You cannot use anything else. You have to use exactly these three compounds. So that is what you have to memorize. That is what you have to study, right? I hope you will study this and finish by tomorrow. Tomorrow night, before tomorrow night, I want you to study these things and finish it. Yes, exactly, Shakina. Only the triple bond will break. Only the triple bond will go to a double bond. Double bond will not do anything, right? Because this is the Lindlas catalyst and it is poisoned, right? It is poisoned. So the catalytic effect is reduced. Okay? Done with it? Okay, let's write another example. Let's write the third one like this. So let's say we have CH3, C triple bond carbon, hydrogen, and then you're adding hydrogen, rain, nickel. Now what's the product? It will directly go for an alkane, right? There will be no double bonds here. Hurry, this will be the product. So you will get familiarized with these things, right? You're just now learning by looking at YouTube. Let's say like you have to drive a vehicle, you want to drive a car. Now what you do is you look on YouTube. Okay, how to drive the car, how to hold the steering wheel, how to put the gear, how to press the clutch and put the gear, right? We are learning through YouTube. You're just looking. බලාගෙන නිකම් කරනවා. But if you want to drive ළමයි, you definitely have to take a car and go in the road. යන්නම ඕනේ. You need to have a person to guide you and then you should drive in the road. Then only you will learn. That is what you should do. If you just attend the class and then watch and then write the note and go home and don't do any questions or anything, you will never be able to understand organic. So number one is memorization. You have to memorize the reactions. Mataka තියෙන්න ඕනේ, definitely you have to remember all the reactions. Otherwise, you will not be able to do. After you memorize, then you can practice conversions. Make conversions practice කරන්න පුළුවන්. Then you will get a hold of organic. Right? Organic reactions, you will get a hold. Believe me or not, lamai, essay question 100 marks out of 150 is allocated just for conversions. 150ක්. That's like 2/3 of the question, right? 2/3 of the essay question. And structured essay question, part B is fully reactions. Fully like mechanisms are also included. So majorly there is reactions. And then there are 3 to 4 MCQs in the MCQ paper. So it's a vast majority of the questions are like organic reactions, conversions. So medica anivaaren definitely have to get a hold. Right? So you are writing A levels next year, August, right? Exactly like 1 year and 2 months remaining. So they will not postpone. I don't think they'll postpone. Right? So it's definitely in August. So next year also it will be in August. So yeah. Done, right? You're done right in this? Raise your hands, everyone. Okay. Then Lamai, the next one you can write the topic, the halogenation reaction. Just like for alkenes, reactions of alkynes with halogens, Cl2 or Br2 is also called halogenation. Hurry. So you have this reactant like CH3C triple bond carbon hydrogen. You're adding Cl2 in the presence of CCl4. You're adding Cl2 in the presence of CCl4, and now what happens? Chlorine will attach from the bottom, chlorine will attach from the top, and then there will be 4 chlorines attached to the 2 carbons. CH3C, Cl, 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 and Cl. This is the product. Let's say like you have this compound and you're adding Br2. Don't worry about this. This is called as a benzene ring. So you draw it like this. It contains 1, 2, 3, 4, 5, 6. There are 6 sides. So there are 6 carbons. So 1 carbon is here, 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 1 carbon is here. And then in the center, you draw a big circle. I will teach you about benzene later. We are learning benzene. So this is also a compound containing 6 carbon atoms and then 6 hydrogens. So yeah, attaching that to this compound, nothing will happen because you attach it, just the reaction will happen. CCl4 normal reaction where the alkyne will be converted to something like this by attaching the Br atoms. Br here, and hydrogen here. Write this down. How can I prepare myself for third term FWC though I have studied till 5th unit? Eva ganan ganna epa now. Don't worry about those things. Getting prepared for term test and getting prepared for A levels are two things. Term test is something which they do to test your current knowledge on the syllabus. It's not a must. You have to score high. There are students who score like 40 marks or 50 marks for term test, and then in the A level paper they get 3 A's and they go to medicine or engineering or whatever the faculty they want. It'll change with time. It will change with time. Anything can be changed within the last 5 months. Just relax, do what you're doing currently. Don't get panicked. First of all, don't get panicked. If your parents are scolding because you have low marks, it's fine. That's how it is. Everyone gets scolded after their term test. Not only you. Everyone gets scolded. Except for the person who is like very perfect. Class first, second, third, everyone else will get scolded. It's just a mafia. Right? Term test is like a mafia. Term test, like they are giving questions. Now, normally tuition classes, like we are doing organic, let's say. So they are giving questions until kinetics. Term test. Like kinetics and questions there. And then they will be like, okay, then in the parents meeting, they'll tell like, ඔයාගේ පුතා class එකේ මෙච්චරයිද කරලා තියෙන්නේ. අපි like in the school, like we have done until kinetics. එච්චර කරලත් නැවල they have just given the note. They have not taught properly. This is the problem. Like they are trying to attack the tuition class. And then the class teacher will be like, hey mother, I am also doing classes a group class. Then අපි නම් මේ ඉස්සරහා යන්නේ දැන් kinetics වගේ යන්නේ අපි. පුතාව ඒකට දාන්නකෝ. Put the child to our class. අන්න එහෙම කරලා like they are trying to promote them. Not all the schools, but majority of the schools are like this. What they do is they give a paper like you can never write, and then they will show you that you can't learn chemistry or physics from your tuition class, and then they will take the students to their class. Their small group class of like 10 students, they'll take you to there. That is the normal procedure. That is why school teachers give term test papers. No, I'm not starting 2028 theory. ළමයි මේ වැඩ වැටියලා දෙන්න. හරිද? Like for example, like in the university, in our university, the science is like very complicated. The academic is very high. හරිද? මට 28 class, if I start, it's going to be a big mess here, right? So I'm doing the revision. Like I'm a person who likes revision classes. I'm doing revision classes for like 2026 batch, 2025 batch. 27 class, I tried it as a trial. මම මේක නිකන් trial එකක් විදිහට පටන් ගත්තා, and I'm continuing this batch and I'm finishing this batch. මම මේක කරලා ඉවර කරනවා. And then after that, I'm not starting any theory classes. In future, maybe I'll change my mind and I will start. But currently I'm not planning to start any theory classes. You are the only theory batch I have, so I'm going to complete this theory batch and then finish you guys off. May revision revision I'm doing every year. Revision is what I like. Revision කියන්නේ ඉතින් අර මෙහෙමයි. In the revision class, it's just like the theory class. The only thing is like we are having 2 to 3 classes per week and then we are trying to cover the syllabus fast within like 8 months. Okay. So that is the halogenation reaction. Then we have hydrohalogenation. Hydrohalogenation type 1. So hydrohalogenation type 1 lamai CH3 C triple bond carbon hydrogen. Now you know what is the product. When you add HBr, one Br will attach to the innermost carbon, other Br attach will attach from the top. So you have a carbon with 2 Brs attached because it will attack 2 times. One Br from the top, one Br from the bottom. And then this carbon you will form CH3. There you go. 2 Brs will attach to the central carbon atom. Right? 2 Brs will attach to the central carbon atom. Okay. So Lamai now previously you learned about diols, right? In like I told you there's something called diol. This is a dihalide. This is called as a dihalide because there are 2 Br atoms attached to the carbon. So there are 2 versions of dihalides. There is like geminal dihalides, there is vicinal dihalides. I'm going to teach you this under alkyl halides, then just write it as dihalide. Even diols, you have vicinal diol and geminal diol. So you're going to learn that later. Actually, that part is also not in the syllabus. They got syllabus again, but some school papers, they ask these things. So don't get demotivated by term tests. That is how it happens. I'm telling this with like 4 years of experience. I know it's not much. I am still 22 years old. I'm a first year student of University of Colombo. So I did my A-levels in 2023. 2023 first try I had a result B, B, C. Chemistry, physics, and biology C. This is my first try result. Second try I wrote again, and I started to get more interested in chemistry than anything else. So I landed with a result like this: A, B, B. This is chemistry, and this has 46 MCQs. And physics and biology, I got a B. And like I still don't know why I got a B for biology. I wrote everything, and then like it's a big theory under biology thing. You have to go for a proper class for biology. Like I did alone in my second try, I did biology alone. Maybe that is the reason. I didn't have a proper idea about how to write essay questions in biology. Maybe that's the reason. Then I started liking this thing more. So I ended up in the University of Colombo and I'm following chemistry, right? So this is my journey where I saw my friends mess up, my students mess up when I'm a teacher. Like some students mess up because they don't revise properly, they don't attend the classes properly. Like different kind of things are there. And also like all of the students I have faced, even the class first in the beginning, he had only 50s to 60s, 40s to 50s. That is how it goes, right? Low marks in the beginning. And then it will increase very slowly until the end. Okay? I'm from Dharmaraj. I'm from Candini. Hurry. So, are you done writing this? Hydrohalogenation type number 2. So the other version of the reaction you can write is the same thing, Lamai, just the Br is attaching to the terminal carbon in this case. So CH3, C triple bond carbon, H, and we add HBr, H2O2, and then the 2 Brs will attach to the terminal carbon, right? 2 Brs will attach to the terminal carbon. Right? So there you go. හරි. හරි ළමයි මේ මේක ලියා ගන්න. Write this down. You have to definitely study alkanes, alkenes, alkynes. මේ තුන අනිවාර්යෙන් you have to study. So I will ask you something. Can you join tomorrow morning at 7 for a small 40-minute session? Small 40-minute session tomorrow morning at 7. Only if you can, only I'm keeping this. Like let's say like more than 15 students raise their hands, I can keep this. Tomorrow morning at 7 to 7:45. One small session. 7 to 7:45, one small session tomorrow morning. It's free, like you can join. Can you join? Raise your hands if you can join for this. Only 15 students raise their hands. I'm going to do this. Those who can join, raise their hands. 9. Only 9 still. Others can't. School, right? Okay, fine. I'm not doing it. Okay, fine. Because I thought of not overloading things to you because you will get fed up. Like my class free like if I do a lot of things to you and you have to study a lot of things, you will get fed up of everything. So I thought of doing only these 3 topics for today. I wanted to do alkyl halides also, but now is not a good time to do it because you will get fed up of the class. Right? I mean, you don't like it. So I'll give another day for you. And then I'll cover it within this week, the small 45-minute session. Alright, so the next one is hydration. I can send it as a recording for the ones who can't join. But the thing is, I would appreciate if all the students join to the live class. No, I don't prioritize recordings. I will give the recording, but I don't recommend you to watch recordings, which is very boring and you will get fed up of the class and eventually you will fall out of the class and fall out of the syllabus and everything will be done if you start watching recordings instead. It's not going to work. Okay, then you have hydration. There's nothing to write there. I have given the reaction. You can read that part. In the presence of Hg2 plus and dilute H2SO4, one molecule of water adds to an alkyne producing an enol. What is this enol, Lamai? So you can see there is an enol. So first of all, what happens? CH3, CH, triple bond carbon CH. So you have this compound and then you add Hg2 plus dilute H2SO4. Right, Hg2 plus dilute H2SO4, and then what you are going to form is something like this: carbon, double bond carbon, OH, hydrogen, hydrogen, and hydrogen. This is the product. This is called as an enol, right? This is called as an enol. Okay. Any questions? Okay, I will answer that. So should we continue school right now if it's not very useful? What do you recommend we do? We can join tomorrow if we don't go to school. I won't tell you not to go to school. You should go to school. My school because they are doing practicals and if your school is okay. Actually, our school, they did practicals and they taught well. Like that's why we went. If they're not teaching, not doing practicals and teachers are not coming, don't go. You can stay home and study instead. Because every syllabus, every subject, tuition classes are taking the maths into their shoulder and then only doing everything. Because tuition classes are the people who are like completing the syllabus for you and giving and doing questions and paper classes and everything we are giving for you. And then like school teachers, some schools are good. I'm not telling all the schools. Some teachers are bad. Like, I mean, they are not coming to the school. They are just reading the resource book like in the bio class. So depends on the school which you're going. Like in our school, they did properly. Is it possible to cover the whole chemistry syllabus beginning in 1 year? Yes, you can do the chemistry syllabus in 1 year. Actually, in the revision class, we covered the syllabus in 8 months, the full syllabus. Normally, that's how we do in the revision class. So does the practical are needed to exams? Yes, practicals are needed, especially in physics, chemistry also needed. physics වල අනිවාර්යෙන් ඕන. Definitely there will be like 4 structured essay questions all from practicals. Physics you definitely have to do the practicals. Alright, so this is called as an enol. This is an intermediate and this is unstable. This is unstable intermediate, right? This is an unstable intermediate. This will not exist. They existed now, right? It will spontaneously decompose into a aldehyde group. It will convert into something like this. It will convert into something like this: CH3, C double bond oxygen, hydrogen. Right? So this is the product that is formed. Right? This is the product that is formed. Addition of water to alkynes take place according to the Markovnikov rule as shown below by the reaction of propyne. So let's write another reaction. Right? So for example, CH3, C triple bond carbon, hydrogen. So when you add, I'll ask one more thing. Can you remember alkenes? Alkene hydration, can you remember? In alkene hydration, what we did was CH3, CH double bond, CH2. We are adding dilute H2SO4. Dilute H2SO4 into this lamine, the OH will attach to the centralmost carbon, right? This is what you meant by hydration in alkenes. But for alkynes, adding dilute H2SO4 is not enough. Not enough. Madi. Right? Not enough. So you give something extra. What is that something extra? That something extra is Hg2 plus. Right? That something extra is Hg2 plus. So we add Hg2 plus and dilute H2SO4. Then only the reaction happens. Now, Lamai, the product of this will be something like this. Not OH. Actually, this is formed. මෙහෙම එකක් හැදිලා කියලා හිතමුකෝ. Like, let's say something like this is formed because two OH should attach, right? Because this is an alkyne. So two OH should attach. So what happens? This is unstable and it will go to compound like this. මෙන්න මෙහෙම එකක් හැදෙනවා. It will go to the innermost carbon. So in the previous example also we learned this where ethine, right? This compound was reacted with the Hg2 plus dilute H2SO4. There you get an aldehyde. එතන ඔයාට එන්නේ aldehyde එක. So in this case you are getting a ketone. Always the carbon double bond forms to the inner side. Carbon double bond oxygen forms to the inner side of the molecule, right? Carbon double bond oxygen forms to the inner side of the molecule. Hari, write that down. Okay, then have a 5 minutes break again. Have a 5 minutes break, Lamai. We'll start the class at 9:07. You know what to do. Don't use phones. Don't use screens. Stay away from screens. So we'll start at 9:07. Right? 9:07. Okay, still not started. 2 minutes more. So the last two reactions we have oxidation in basic medium and reactions of terminal alkynes. Okay, right. So the next one is oxidation in basic medium. Right, oxidation in basic medium. You can read that part. Addition of KMnO4 in the basic medium will cause 4 OH groups to attach to 2 carbon atoms. This would be unstable. So 2 OH groups for 1 carbon atom are not existing. It's unstable, right? I told you that. So therefore, it will undergo condensation, removing water to form a compound as shown below. So what happens is, Lamai mein, you have CH3C triple bond carbon hydrogen, right? So you add OH minus KMnO4 cold dilute conditions, right? Cold dilute conditions. Now what happens is there will be 4 OH groups, one here, one here, one here, one here, and a hydrogen here. This will be extremely unstable. So the OH will leave with one hydrogen of the neighboring carbon. This OH will leave with one hydrogen of the neighboring carbon. It will leave out of the system. So now when you erase everything out, you will form this compound CH3, C, oxygen, C, oxygen, C, sorry, hydrogen. Now, Lamai, the carbon and hydrogen will form another bond, forming a double ketone compound. Right? It will form a compound like this. Hari? It will form a compound like this. So there you go. Hari? Make it productive. Hari. That is that. So this is the reaction with the basic medium. Then the last one is the seventh one, reaction of terminal alkynes. Reactions of terminal alkynes. So you can read that part. The triple bond carbon atoms are sp hybridized. A CH bond involving a triple bond carbon is formed by the linear overlap of a sp orbital of carbon and a s orbital of hydrogen. Since a sp orbital has more s character, like 50% s character, than sp2 or sp3, the bonding electrons in CH bond in alkynes are closer to the carbon nucleus than in the case of CH bonds in alkenes or alkanes. Now, this is an explanation why alkanes does not react with terminal alkynes to form terminal alkynes. For example, it's like this. Now, you have this reaction where you react terminal alkynes with sodium. Now, when you add sodium, what happens is this hydrogen will get displaced out of the molecules. And then you will form something like this. Carbon, sodium plus and C minus. මෙහෙම එකක් හදනවා. හරිද? And hydrogen will be liberated. Hydrogen will be liberated out of the system. Hydrogen will be liberated out of the system. So this is the reaction normally that is happening. Why doesn't this happen for alkanes? Why doesn't this happen for alkanes? Because the hydrogen is not connected to a carbon which is electronegative, which is much electronegative. Now this carbon is sp hybridized, right? So sp hybridized is enough to react with sodium. This hydrogen will get removed easily, right? Because of this sp hybridized carbon. But in this case, it is sp3 hybridized carbon, which is not enough. Even alkene is not enough. Right? Even alkene is not enough. Here also the hydrogen will not react. So if you react with sodium, no reaction will happen. So it will react with sodium-like metals like this in order to liberate hydrogen gas and then form terminal alkyne. You call this a terminal alkyne, right? You call this a terminal alkyne. Sorry, this is a terminal alkyne and it will form a salt of terminal alkyne. So you can write it here. Terminal alkyne, which will react to form salt of terminal alkyne. Hurry. Salt of terminal alkyne. Please write this under that blank given. Hurry. Then lamai, the next one, the last two reactions you're going to learn today. Last two reactions we are going to learn today. Terminal alkynes react with certain heavy metals such as Ag plus and Cu plus in order to form insoluble metal acetylides. These two reactions can be used to identify terminal alkynes. So reactions like this will also happen. So CH3, C triple bond carbon hydrogen. This will react with AgNO3 in the presence of ammonia. So both you have to add AgNO3 in the presence of ammonia. This will react to form triple bond carbon and Ag will attach to the carbon and now this will form a precipitate. It's a white color precipitate. It's an identification method we are going to learn later. Now this is also learned as a reaction, so that's why I gave this. So you have this also where we attach a copper atom. So Cu2Cl2 in the presence of ammonia. Cu2Cl2 in the presence of ammonia where copper is in +1 oxidation state. So copper will attach to this to form a Briggs red precipitate. Right? It will form a Briggs red precipitate as shown. So this will give precipitates like this. These two are precipitates. This is not a precipitate. මේ උඩ එක precipitate එකක් නෙමෙයි. So these are water insoluble. These two are water insoluble. You have to write these two below that diagram, below that sentence. You have to write these two below that sentence like terminal alkynes will react with certain heavy metals. Under that part only you have to draw this. Hurry. Okay, lamai. So the basic building step for organic is done. Right? This is the basic. This is like giving you an idea about what is organic and then starting organic and then doing alkanes, alkenes, alkynes for you. Now, what is our website? So what is the website? It's rchem.lk. It's a .lk website we have. It's a registered website. So you can go to that. I will screen share you website appearance and everything and how to make a payment through the website. I'll teach you in the recording so you can use that. You can familiarize with it. So it's a nice website. So you can search rchem.lk. Oops, it didn't search properly. Sorry, rchem.lk. So you can go here, you can see this is the opening page of the rchem, and if you have already signed up, then go to dashboard. But if you are not signed up, If you are new to this website, then you can go to sign up, and then you can enter your details. You can enter your details, your first name, last name, and the email address and the password and stuff. Now I have already registered, so I'll go to dashboard. So you can enter your details here, which you have used to sign in before. So this is your dashboard where you can access all the recordings and your marks and everything. So you can see the marks are given here. The rank is also given. So this is a test mark. So you can see here how your marks are going to vary. I'm going to add it into your website. So this is the main exams, right? So we have had 4 main exams until now. So that is that. Then the performance curve is there. So you can check your performance in the class through this. And then there's the class store. Now we can buy classes which you want. Now this is for 2026 students. In 2027, you don't see this rapid revision and everything. So if you want to enroll in something, then you can press on enroll now. And then you can make the permanent payment to the bank details given here. And then you can select like Hatton National Bank or Commercial Bank. You will see the bank details. And then you can upload the receipt to this place where you see here. Right. Then you can press on submit payment. And then your payment will be recorded. So those are the things I wanted to show you. So yeah, that's that. You can see the payment details and everything. I'll send you in the group how to join with the class. So once you join with the class, Lamai, you will get that gift I told you. So from the first 6 units, you will need to select 1 unit. So from that 1 unit, I'll give you a self-study pack from YouTube. YouTube recordings. I will give you that set of links, and the tute I'm going to courier you. The self-study pack tute I'm going to courier you, and you will get it. Okay, so you can leave the meeting. That's all for today. Now, if possible, I will send you a recording for alkyl halides. Alkyl halides mang iwanna. There's a question, sir. What's your opinion about practicing chemistry paper book? Chemistry English medium paper book has a lot of errors. Errors. You can try the questions, but make sure you try it by having some idea about the errors that they make. Some questions answers are wrong. I even scolded them by emailing them one day, like when I was doing A levels. English medium like lot of answers are wrong, and the pronunciation, the grammar is wrong. Pronunciation, grammar, right? The grammar is wrong. So I recommend you to do past papers as a raw past paper. Again, past paper question select it's good. I did it like that. If you want to do paper, then you find you can select the question. Then you want to practice questions under organic. So you will see the exact question number from the year. That is useful. You can use that as the method, but don't trust the answers much. If you have any issue, you can let me know. I will help you out. Okay. Okay, then good night. You can leave the meeting.